Solve the inequalities. All right, so again, we're going to repeat this idea of finding the zeros and vertex of the function and then graphing it to answer the inequality, right? So first thing we're going to do is go ahead and find the zeros. So we're going to change this to x squared minus 4 is equal to 0. And then we can factor that. That's a difference of two squares. So we'll factor it as basically x minus 2 and x plus 2. Remember, we find the roots of the two pieces and then do plus or minus between them. Then from there, the zero factor property allows us to separate these. So we can do this. And finally, we can say that x is equal to 2 and x is equal to negative 2. Those are the zeros of the function. Now, if you want to find the vertex of the function, you can just simply do the negative b over 2a for the h part and then plug that in for the y part. So negative b over 2a, in this case, there's no b term, right? There's no x term. So we would say that negative b is just minus 0 over 2 times 1, and of course that'll give you 0. And then if you want to know what the y-coordinate of the vertex is, which we call k, you would just plug the 0 in for x, and you'd get 0 squared minus 4, and then of course that's just equal to minus 4, right? So we have our h and k, so our vertex, in other words, is equal to 0, comma, negative 4, and we have our two zeros, right? Our zeros of the function are simply 2 and negative 2, right? All right, now we're going to use those to graph the function. So we'll create a little graph by drawing a little rectangular coordinate system. And then from there, we can put the vertex on it. So 0, negative 4 is at 1, 2, 3, 4 on the y-axis, on the negative side of the y-axis. And then positive 2 is the first 0. And at x equals negative 2, we have the second 0. And if we go ahead and draw the parabola here, we're going to have it going up because the x squared there is positive, right? And that's our drawing. And the reason why we want the drawing is because now we can answer the question, where is the function less than 0? In other words, where is it below the x-axis? Well, I think it's clear that it's below the x-axis here, right? And so basically that's between the two zeros on the x-axis. That'll be between negative 2 and 2. So our answer for this problem is just that we're less than 0 between x equals negative 2 and positive 2. And we use round brackets because we're not saying less than or equal to 0, we're just saying less than 0. So that's your solution. All right, let's look at example B. For example B, we need to first rewrite the function. So we might want to say that this is 3x squared. I'll bring over the 10x to make it negative 10x, and bring over the 8 to make it positive 8. And that's equal to 0. At that point, we can then again find the zeros and the vertex of the function. So let's try to find the zeros first. We'll see if this is factorable. It usually is. So we're looking at splitting up 3 and x in the front position. That way we have 3x squared when we multiply those two front positions. And then when we look at the 8 at the back end, the 8 would be probably 4 and 2, or we could even try 1 and 8. Let's try 4 and 2, however. We could try the 4 here and put the 2 here and see what that does. All right, so if we did the inside product, we get 2x. And if we do the outside product, we get 12x, right? And if you were to add these together, and why am I saying add? Because this sign here on the right is positive. So we have to add. And if we added these, we actually get 14x. So that's not the right answer. So that won't work. All right, we can try something a little different. We can try, for example, switching the 2 and the 4. So let's put the 4 here and put the 2 here, and then what happens? Well, that inner product becomes 4x, and the outer product becomes 6x. And then we do indeed get the 10x that we want to get. Now, because it's positive on the right and negative on the left, we know we'll have two negative signs for our factoring. And then we're good. We factored it, and we can say, okay, there's a product now equal to 0, so that'll be 3x minus 4 is equal to 0, and x minus 2 equals to 0. And then if you solve this first one, it'll be 3x is equal to 4, and therefore x is equal to 4/3. And for the second one, we'll find that x is just equal to 2. So those are the zeros for the function. So let's just write those over here. The zeros are 4/3 and 2. All right, good. So we have that. Let's do the next part, which is to get the vertex of the parabola. So to get the vertex of the parabola, remember we're going to do that h idea, which is negative b over 2a. And negative b in this case would be negative 10, or in other words, positive 10, all over 2 times 3, which is 6. So we have 10 over 6. And then you can reduce that by dividing 2 into both. So you'll get the answer 5/3. All right, so that's your h coordinate. And then if you want to plug that into your function, you can get the k coordinate if you're interested in that. Again, we don't strictly need that because you can just figure out where the vertex has to be based on the structure of the parabola. But let's plug it in. If we wanted to see what it is, we could do that. And if you do that, you end up getting -1/3. So again, we don't need to have that k value, but if you want to plug it in, plug the h into the function and figure out what that gives you, you can get the -1/3, and it helps you figure out that the vertex, of course, is then at the point 5, 3, -1/3. All right, now let's go ahead and plot the vertex and the zeros on the graph so we can get a quick sketch of the function. All right, so the vertex is at 5/3, which is basically like 1 2/3 or almost 2. So I'm just going to put on our graph here 1, 2, and put the vertex somewhere there, and then down -1/3. So it's basically right there, the vertex, very close to the x-axis, right? But definitely below the x-axis. And I know it's below the x-axis because the other information I have is that the zeros are at 2. So that would be right here on the x-axis at 2. And then 1 1/3. So that's just next to that right there. So we have a function that's very close, right? Very, very, very close to the x-axis, but it is technically below it. And the reason why I know this, again, is because if I have zeros, right? Think about it. If the function is going to open up because of the fact that the coefficient in the front of the x squared is positive, if I know it's going to open up, and I know it crosses the x-axis, the vertex has to be below the x-axis. And that's basically all I care about, right? I really just care about where the zeros are located and the fact that the vertex is going to be somewhere below the x-axis. So I technically don't even need the vertex to graph this, but it's just the idea that by being able to put the vertex there, I can get a better sketch. And since it's so simple to get the vertex, we've been doing it in the problems. But essentially find the zeros, know whether it opens up or down, and you could do the same thing we've been doing all along here. All right, but either way, once we look at that, then we can answer the question, where is that function less than 0? So remember, what we're trying to show ultimately is that 3x squared minus 10x plus 8 is less than 0, right? Because when we moved everything over to the left, we had the idea that the equation was less than 0. So we're asking, where is this true? Where is it below 0? Well, again, that'll be wherever it's below the x-axis. So we're just talking about this little teeny piece of the graph right there that's below the x-axis. And where is that occurring? Well, it's occurring between the two zeros. And those two zeros are basically at 4/3, right? And 2. And again, we'll just say that we're going to round the brackets because we don't have less than or equal to 0. We just have what? Less than 0. So we're using parentheses as opposed to square brackets. And that means that our solution for the problem is simply from 4/3 to 2. That's the place on the x-axis where the graph is below the x-axis. Or in other words, the place where the y is negative.